Hey there guys, and welcome to this video on making soluble salts. So we're going to crack on and have a look at exactly what salts are. We're going to have a look at the differences between a soluble and an insoluble salt. And finally, we're going to have a look at the experimental procedure in order to produce soluble salts. Okay, so let's have a look at that right now. Alrighty, so first of all, what is a salt, right? Well, salts are substances made when acids react with metals, metal hydroxides, oxides, or carbonates, right? Basically, they're generally made of metal ions, okay, combined with non-hydrogen portion of an acid, right? So, for example, let me just draw an example for you. Let's say I had something like calcium carbonate, which is CaCO3. Let me actually use a bigger pen because you probably can't see that. Let's say I had calcium carbonate, CaCO3, plus HCl. Well, I can predict straight away what salts I'm going to get, right? I'm going to get calcium, so the metal, and then the non-hydrogen part of the acid, chloride, right? So that's calcium chloride, right? I can go a bit further than that and predict the formula based on the charges. Well, calcium is in group 2, so it's got a 2 plus, and chlorine is in group 7, so it's got a 1 minus, making that CaCl2. That is how you balance, right? You look at the charges, they must balance. By the way, when you've got an acid, let's say it was nitric acid, right? HNO3. Now you're not going to have a look at the group that NO3 is in, because obviously that's two separate elements. Instead, with an acid, it makes it nice and easy. Just look how many hydrogens it's with, right? It's with one hydrogen, and hydrogen is always plus 1, which means nitrates must be minus 1. So calcium nitrate would actually be CaNO3 2, because you still need 2 of those to balance the 2 plus charge of the calcium. Okay, right, so that's what a salt is. Moving on, we need to be able to produce a soluble salt. Now, just very quickly, what do we mean by soluble? Soluble means it dissolves in water, which means if you've got a solution, right, the soluble salts will dissolve into solution. If you have an insoluble salt, right, let's say, for example, calcium carbonate, if you put that in water, it stays as calcium carbonate. Okay, or it stays as solid calcium carbonate, right? And that's what I mean. So you don't get it dissolve into the solution. You can still see the solid particulates in there, right? And that's actually the basis for the lime water test for carbon dioxide. But we look at that in another video. But that's the difference between a soluble and an insoluble salt. The reason why we say this is that a soluble and insoluble salt are produced in different ways, because one of them is soluble in water, the other one is not. Okay, so producing a soluble salt, we must react an acid with an insoluble, right? An insoluble substance such as the metal oxide, or metal carbonate, right? The reason for that is so that there's no confusion as to what is what. If one's insoluble and one is soluble, then it means that you can actually separate solid from liquid, and that is great. Okay, so then what do? We carry out the reaction until completion. So what does that actually mean? Well, let's say, for example, I had a beaker, right, and that beaker had acid in it, and that acid was hydrochloric acid, right? And so I had hydrochloric acid there, and I put some calcium carbonate in. Yeah, I'm just using the same reaction that we had before. Calcium carbonate is not red, right? But let's just say I chucked it in and it was a big red block of calcium carbonate. What would happen is you would get bubbles given off because you produce gas as a result. But you would also produce, as we saw before, calcium chloride. Now, calcium chloride is soluble, right? Let me actually write out the equation for you just very quickly. All right, like so. So, look, calcium carbonate is solid. Right, calcium carbonate is solid. Calcium chloride is aqueous, which means it is in solution. And so you also produce carbon dioxide, which is a gas. So you're going to get bubbling of the gas as your calcium carbonate disappears. And then boom, that is completion. Once it's gone and the bubbling stops, then it's completion, and we know that all the calcium carbonate has turned into calcium chloride, water, and carbon dioxide. Right, that's what we mean by completion. Now, here is the clever part, because at the moment, if all of your calcium carbonate is gone, it means we don't know if we still have hydrochloric acid left over. You probably do, is the answer to that. But we don't want hydrochloric acid there. What we want to produce is this salt. Right, we want to produce calcium chloride salt. Let me get rid of all those other white lines because it's kind of annoying. Yeah, that's what we want to produce, not hydrochloric acid. So we need to get rid of the hydrochloric acid. Well, how do you do that? You add more solid until it is in excess, right? So going back, what you do is you keep adding more of your calcium carbonate. Remember, it's not red. and it will keep reacting until eventually it stops. And when it stops and you still have solid left over, then you know that all of your hydrochloric acid has actually gone, right? And so you're left with an excess of calcium carbonate, right? So if you were to think like checkpoint, what do we have right now? You have excess calcium carbonate still in there as a solid, but everything else is definitely water and calcium chloride because we've used up all of the hydrochloric acid, right? That's cool because now we can separate those things. So then what do we do next? Okay, right, great picture. Then hang on. I skipped on to the next slide. So then what do we do next? We filter off the excess solid, right? That's the part I didn't say. We filter off that excess solid. So this calcium carbonate which is left over, we pour the solution through filter paper and the solid will not go through. What will go through is only, not this, the calcium chloride and the water. That will go through, the calcium carbonate will not. Okay, and so then what we would have is just calcium chloride solution, right? So calcium chloride solution, that's what we'd have. That's great. Then what do we do next? Okay, then we need to heat the remaining solution to evaporate the rest of the water off, right? So we evaporate the solution until crystals start to form. This is very important, right? You don't just burn it for as long as you can, right? You heat it until the crystals start to form. Okay, when that happens, then you transfer it into what we call an evaporation basin, which is actually just a really fancy word for like a tray, which is quite wide, right? So you basically put it into this evaporation basin and then you leave it out overnight and crystals form overnight. And that would be our crystals of our soluble salt, right? And that is it. So that would leave us with our crystals, in this case of calcium chloride. And so perfect. One thing to mention is that some salts, right? For example, sodium chloride, table salt, you wouldn't get this part. You wouldn't actually have crystals start to form when you still had some water left, right? Other ones you do. So if you don't get crystals forming when there's still water left, then you just heat until all the water's gone, okay? But any salts which can form a hydrated salt, as we call it, once most of the water's gone, crystals start to form and then you stop, right? And then you would form the hydrated crystals as a result. Okay? So that is basically it. So if you were to consider the steps again, let me just run through them. You basically take an insoluble substance, right, which is a metal oxide or metal carbonate. You react it with an acid in order to form a soluble salt, right? But you need to make sure that that reaction happens to completion. And then you need to add solid until the solid is in excess. That gets rid of your acid. Once it's in excess, you then filter off the solid. Then you know for a fact you have a solution of your salt, right? Containing your soluble salt. Then you heat it until crystals form. Once crystals form, then you transfer it to an evaporation basin and then you leave it overnight or leave it for as long a period as you like in order for crystals to form. Generally, the longer you leave it, the bigger the crystals, and so that's really down to you. Okay, so we're going to stop there. I hope that made sense. If you do have any questions, feel free to post them in the box below or send me a direct email. But as usual, please like and subscribe because it does help me out and you'll be notified of new videos as they become available. Thank you very much for listening. I look forward to seeing you in the next one.